Hello, welcome back. In this video, we'll be learning about preemptive priority CPU scheduling algorithm. In the previous video, we have learned about priority scheduling and also we learned an example on non-preemptive CPU scheduling algorithm. In this, we'll be using your preemptive CPU scheduling algorithm method, which is based on the priority, will be scheduling the process to the CPU, and also whenever there is an equal priority, whenever there is a two process that is coming in, and whenever it has a two equal priority, we'll be using your FCFS, and then we will be taking the chain and then giving the process to the CPU. We'll take a problem and we will solve how preemptive priority CPU scheduling works. Let us consider the problem with process P1, P2, P3, P4 and P5, and arrival time, priority and the burst time is given. We need to find out completion time, average turnaround time and average waiting time to the given problem. Now here we are considering lower the number, higher the priority. So whichever has a low number, that has higher priority. So 2 is the lowest number, so it starts from here. 2 will be the first one, third, then 4, 6 and 10. So this will be the priority order that we will be seeing. Now during 0th millisecond, that means initially when you started to schedule the process, there is only one process that has arrived in the ready queue, that is P1. P1 has arrived and there is no process that has arrived at 0th millisecond. So you don't have a choice. You will be assigning CPU to P1 itself. I'll draw the Gantt chart here. At 0th millisecond, you're assigning for P1, and usually whether the process comes in or don't come in, it will always complete the task for 1 millisecond. So here also P1 complete the task for 1 milliseconds. What's the burst time? Burst time was 3. It has completed for 1 millisecond. Now during 1, there is a process called P2 that arrived in the ready queue. Now see the priority of P1 and P2. P1 had a priority called 3, P2 had a priority called 2. That means P2 had a highest priority. So what you'll be doing, you will be stopping your P1 at 1 millisecond, and also please update the burst time. Here it was 3 minus 1. So it will be 2. This is the updated time of P1. Now what we will be doing is P2 comes and gets the CPU. P1 will be sending to the ready queue. Now P2 will get the CPU. Irrespective of who comes, it completes for 1 millisecond, that is 2 millisecond. So when it completes at 2 millisecond, again we have to see which is the process that is coming in. P3 comes in, but P3 has 4 millisecond. That means it's a lower priority. So you'll complete for another 1 more millisecond till 3. During 3, who comes in? P4 comes with 6th priority, which is slightly lowest compared to P2. Then again it completes for 4. There is no process that is coming during 4. Then there is 5. It completes till 5. During 5, there is a process, that is P5, that came into the ready queue, which has a priority 10, which is lower compared to P2. So P2 had a burst time of 4, 1, 2, 3 and 4. It has completed for 4 millisecond here. So P2 is done. Now here we have to check the priority. P1 had a priority 3, P3 had a priority 4, P4 had a priority 6, P5 had a priority 10. In this, which is having a lower priority, P1 has a lower priority. We have to give the CPU to P1, P3 remains as it is, P4 and P5 remains as it is. P1 goes, P1 already completed the task for 1 millisecond, so the left is 2. That means 5 to 6 and 6 to 7, P1 completes. Then you will be giving the CPU to P3, P4 and P5 remains as it is. P3 have a burst time of 6. So 7 plus 6. P3 task is done. Now we'll be giving for P4, since it has 6 and this has 10. So 6 is slightly higher compared to 10. So P4 will be going and P5 remains here. So P4 had the burst time of 4. So it will be 18. It will be 17. 4. P4 is done, and the last process that is left is P5. So P5 goes, it has a burst time of 2, so 17, 18, and 19. Now, if you want to check whether the last completion time of the entire process is correct, then you have to total the burst time. The total burst time, the total whatever you get as a total burst time has to be equal to the total amount that you're getting at the end. So we had 3, so 3 plus 4 is 7, so 7 plus 2 is 9, 13, and 6 is 19. So total you're getting 19. That means my answer is correct. You cannot say the Gantt chart is correct, but you can say the answer, the completion, the total completion time, that is 19, is correct. But we cannot say my Gantt chart is correct because the arrival time and also the priority can differ. Now we have to calculate the completion time. When did P1 completed? It completed at 7. P2 completed at 5. P3 completed at 13, P4 at 17, and P5 at 19. So this is the completion time. Now we have to check for turnaround time. So we already know the formula for turnaround time. It is CT minus CT minus 80. So 7 minus 0 is 7, 5 minus 1 is 4, 13 minus 2 is 11, 17 minus 3 will be 14, 19 minus 5 will be 14 again. So this is your turnaround time, and your waiting time will be turnaround time minus the burst time. So 7 minus 3 is 4, then 4 minus 4 is 0, 11 minus 6 will be 5. Then turnaround time is 14 minus 4 is 10, and the next one is 14 minus 2 is 12. So this is your TAT and WT. You also need to find out average turnaround time. It will be 7 plus 4 plus 11 plus 14 plus 14 divided by 5. The answer would be 7 4. So 50 by 5, that would be 10 millisecond, and average waiting time would be 4 plus 5 plus 10 plus 12, that is 31 divided by 5. You get it for 31 divided by 5, 6.2 millisecond is the answer for preemptive priority CPU scheduling algorithm. If you see here, the process P1 has not completed the task. It completed only for 1 millisecond. Since P2 came, it gave up the CPU. Then after that, it came and completed its task in the CPU. So this is called preemptive priority CPU scheduling algorithm.